Okay, so today we're going to be solving this equation, which is 3x plus y equals negative 2 and negative 2x plus y equals 8. So what you want to do is you want to get one of the coefficients to be opposites of each other so they could cancel out. So technically you want a positive and a negative so they could cancel out, and they have to be the same coefficient or number or amount. So what I'm doing is I'm going to get the y coefficients to be opposite. So I'm multiplying 3x plus y equals negative 2, the whole equation by negative 1, which is negative 3x plus negative y equals 2. So then when I do add negative 2x plus y equals 8, the y coefficients will cancel out. So then I'm going to be adding, as I just said, so I'm adding negative 2x plus y equals 8, and I'm going to then cross out or cancel out the y's because they are opposites of each other. So those don't matter, so I'm just going to cross out the top equations just so everything's neater and I don't confuse myself. So I'm just going to cross that out with a squiggly blue line, and I'm going to add. So 2 plus 8 is 10. I did start from the right, but you could, I don't know, you just start wherever. But negative 3x plus negative 2x is negative 5x. And I'm just crossing out the y coefficients right here just to show you that they don't really matter in the equation at the moment. So I'm continuing on with the equation and dividing both sides by negative 5 to get x alone and to solve for x. So x is negative 2 because negative 5 times negative 2 is 10. So now to find what y is, you want to plug in x equals negative 2 into one of those equations. So you're going to substitute x as the value of negative 2. Yeah. So I'm just going to use any one of those equations. So I'm doing negative 2x plus y equals 8, and I'm substituting x for negative 2. So 2 times negative 2 plus y equals 8, and I'm just going to solve. So negative 2 times negative 2 is 4 plus y equals 8, and I'm subtracting 4 from both sides to get y alone, and then you end up with y equals 4. And you find your answers. So that is how you solve the system of equations for that given equation. And the ordered pair is negative 2 and 4. So x equals negative 2, y equals 4. Okay, so next problem, we are going to solve for 3x minus 2y equals negative 17 and 4x plus 2y equals negative 4 using the system of elimination, multiplication, elimination. Yes, okay. So basically, since we have the same coefficients that are opposites of each other, those automatically cancel out, leaving us with the rest of the equation, which we have to solve for. So 4x plus 3x equals 7x, and negative 17 plus negative 4 equals negative 21. And then I divided both sides by 7, leaving us with x equals negative 3. Next, we're going to get x equals negative 3 and plug it into one of these equations to solve for y. So basically, we're getting 3x minus 2y equals negative 17, which is the equation I used to substitute for x. And so it is now 3. Oh yeah, look, I'm pointing at what needs to be substituted. So negative 3 is now now x. There you go. Okay. So 3 times negative 3 minus 2y equals negative 17. 3 times negative 3 is negative 9. Negative 9 minus 2y equals negative 17. Next, to cancel out the 9 and get y alone, you're going to add positive 9 because the opposite of negative 9 is positive 9. So we're adding 9 to both sides, leaving that now canceled out. Negative 17 plus 9 is negative 8. So then we are left with negative 2y equals negative 8. So negative 2y divided by negative 2y, and negative 8 divided by negative 2y. 2y and over 2y cancels out, and you get left with 8 divided by negative 2y, which is 4. So that is your answer for y. So that is our solution to the problem. 3, negative 4 as an ordered pair. Okay, so next problem, 3x plus 2y equals 3, and negative 3x plus 5y equals 18. So, since we do need opposite coefficients, we need to find ones that cancel out. So 2y and 5y don't, because one of them is a positive and the other is also a positive. But 3x and negative 3x, with the help of my little pointer, do cancel out. So then we just add the rest of the problem, leaving us with 7y equals equals 21, and 7y divided by 7 and 21 divided by 7 is now left with y equals 3. So that is our solution to y, and with the help of my pointer again, we are going to plug in y equals 3 into the equation. So I'm just doing 3x. Well, no, I'm not doing that right now. So I'm doing 3x plus 2y equals 3. So I'm just going to plug in 3 for y. So it's now going to be 3x plus 2 times 3 equals 3. If my pen wants to write. Yes, it does. Okay, 3x plus 2 times 3 equals 3. So, then we're just going to solve. 3 times 2 is 6. 3x plus 6 equals 3. Then we are going to subtract 6 from both sides to get 3x alone, or just to get x alone in general. So we're subtracting 6 from both sides. 3 minus 6 is, 6 and negative 6 cancel out, obviously, because you're subtracting 6. So it's 3x equals negative 3. So then you're dividing both sides by 3 to get x alone, and you are left with x equals negative 1. So a way to check this, just to make sure you are correct, is by just substituting those values using x and y into one of the equations or both of the equations to make sure, so that they would equal what it says it equals. So again, I'm using 3x plus 2y equals 3, and then plugging in x equals negative 1 and y equals 3 into the equation. So it's 3 times negative 1 plus 2, y equals 3, so plus 2 times 3 equals 3. So then we're just going to solve. 3 times negative 1 is negative 3, plus 2 times 3 is 6, equals 3. And we have to see if that's true. So it's negative 3 plus 6, 3. Yes, it is. So that is correct. Correct. Woo, woo. Let's do a smiley face. Yeah, so it is correct.